Right, for question number 2, let's see. Diagram 2 shows the graph. There's a graph. Okay, negative x squared plus x plus c. Negative x squared, that means a is a coefficient, the number that times with the x squared. B is a number that beside x is plus 1, and c is a y-intercept. So we have to sketch the graph of the function fx. Okay, when the following value change and make a generalization from the change in the shape of the graph obtained. So basically when you look at the graph, if you change a graph, the coefficient of the x squared, that means the graph now no longer negative a, become negative 4 x squared plus x plus 6. So the graph will look like this. It will become a bit narrow, something like this, and then come down. Right, so this is when you change the a, so a become negative 4, the wider of the parabolic shape will decrease. Okay, will decrease. It will decrease. The wider means the size here. You become less than original one is this one, from 2 to 3. Now the shape, because it actually come narrower, so it become a bit narrow compared to the original one. Okay, for the y-intercept, it remain unchanged, so y-intercept no changes. So you can write the wider of the parabolic shape decrease, while the y-intercept remain unchanged. Whereas the y-intercept remain unchanged. Right, that is how you interpret or justify your answer. Okay, so we have solved the part whereby the a changed to negative 4. What if for part B? For part B, if we change to, for part B, we have to change the coefficient of the x, whereby the question asks you to change to negative 2. That means the graph right now, it will become fx equal to negative x squared minus 2x plus 6. The y-intercept remain unchanged. So if we change the coefficient of the x, the graph actually will shift to the y-intercept remain unchanged. It will shift to the left, something like this, right? Okay, it's still an N shape. It must be a nice N shape, right? But it shift to the left side, all right? So this is actually the function that whereby we change the b to negative 2, right? So the vertex actually shift to the, we can write we can interpret or justify the answer. So the vertex means the maximum point here. Okay, shift to the left of the y-axis, right? And then all the point change except y-intercept. Even the maximum point also change. We will go higher a bit. This point. Later I will show you. All the point except y-intercept. Okay, change. But the shape still N shape. The shape remain N shape. remain N-shape. The shape unchanged. Right? Okay, so that's how you interpret the changes of the B. If we change the graph by change the value of C for part C, it change to -3. So the function now will become fx equal to -x squared plus x minus 3. Now the whole graph will actually shift down. Okay, the whole graph will shift down, but the y-intercept will be negative. Just now the y-intercept was here, which is 6, right? 6. Now if we change to -3, that means the new graph now is fx equal to -x squared plus x minus 3. So it will actually cut the graph at the y-intercept here, which is here is -3. The shape remain unchanged, still N shape. Okay, that means it move how many unit? It move let's figure out how many unit. It move down 6 unit and another 3, so shift down 9 unit downward. Okay, so the shape remain unchanged. So we can just write the graph shift downward 9 unit, right? 9 units, and the shape remain unchanged. The N shape still remain unchanged. Alright, I will share with you using the graph in my next part of the video. So have fun, bye bye, and have a nice day. So originally the graph is something like this, right? As you can see, the y-intercept is 0, 6, right? And the maximum point is here. If you look at maximum point is 0.5 and 6.25. The highest value of the y is 6.25. The axis of symmetry is x equal to 0.5. And these are the roots. The roots are -2 and 3. Alright, the roots are the actually x-intercept. So we have -2, 0 and 3, 0 are the roots. So originally this is a graph. Let's say if I change the a is a coefficient of the x squared, the number that multiplied by x squared, which is -4. If I change to -4, what will happen to the quadratic function? Will it look wider or smaller or narrower? Okay, let's have a look. This is a blue one. The blue one is the coefficient of the x squared become -4. It become narrower, right? But the y-intercept remain unchanged. The maximum point, there is a changes, right? It looks like lower a bit, right? But still you can see that the maximum point is still somewhere around 6 something, right? Okay, and then the y-intercept is 0, 6, and the x-intercept of course will be -1.1061, and the other one will be 1.35610. These are the roots. The roots are in decimal. So you can see the blue curve is actually when the coefficient of the x squared become -4, whereby the curve become the graph, the parabolic graph become narrower, right? Okay, so this is changes of the A. What if we change the B? Now if I change a B, which is originally is 1, B is a coefficient of the x, the number that multiplied by x. If I change to -2, right, what will happen to the graph? Let's have a look. The curve looks like this. Let's have a look of the graph. Okay, let me shift to the other side first. Okay, it looks like the roots become -3.64575, and then the other one will become 1.645. So if we change the the coefficient of the x, which is negative 2. That means the graph now become this one, negative x squared minus 2x plus 6. The y-intercept remain unchanged, 0, 6, but the maximum point go higher compared to original. The maximum point also change. The axis of symmetry become negative 1, and the highest value of the function is 7. So when we change a b, actually the maximum point change. Only the y-intercept not change. All right. So the wider of the parabolic shape also change. Right. Okay. So this is changes of the b is actually the effect is great to the parabolic function. Now if we change y-intercept, which is a c is a y-intercept, we change to negative 3, of course the graph will go down, isn't it, because of y-intercept, this one. All right, I'm going to show you. If I change a c to negative 3, and it looks like of course the maximum point will change, and the y-intercept become negative 3. All right, so that is the effect of the changes of the value of the ABC to the quadratic function. Again, I'm going to show you again. Originally we having this one, which is negative x squared plus x plus 6. Then we are asking to observe the changes when the a change to negative 4. So this is the blue one. After that, we are asking to change the b to negative 2, right? The b to negative 2. So it looks like the orange color one, it become wider, and the maximum point become higher, and then the graph shift translate to the left, isn't it, right? Translation to the left. Okay, and finally we change the intercept, the graph will translate downward. If we change a b, it will translate left or right, but we change a c, will translate up or down, depends on the c value. If c is negative, it will go down. If c is positive, it will go up, right? Okay, so that is how we explain the changes of the graph when the a, b, c change. All right, so that's all my sharing about the quadratic function.